What if we told you that your distant ancestors had fins instead of feet? That once upon a time, the path to walking on land began underwater, in the murky world of ancient fish. This is the story of evolution's most daring leap, from aquatic life to land-dwelling creatures. From the first bony fish to the rise of amphibians, nature engineered one of the greatest biological transformations in Earth's history. Join us on Evo Chronicle as we dive deep into the story of vertebrate evolution. The saga of vertebrates begins over 500 million years ago, during the Cambrian explosion, a time when complex life exploded onto the scene in a burst of evolutionary creativity. Among these pioneers were early chordates, creatures with primitive spinal cords that marked the origin of the vertebrate lineage. The first true vertebrates were jawless fish, like Hyquichtsthys and Millicunmingia, swimming through ancient seas. These were small, eel-like animals with cartilaginous skeletons and simple eyes. They had no jaws, no paired fins, and no hard bones, but they had something more important, the building blocks of all future vertebrates. As vertebrates evolved, some species began to develop jaws, a massive evolutionary advantage that allowed them to bite, grasp, and chew. These new jawed fish, called gnathostomes, would dominate the oceans and diversify into incredible forms, setting the stage for the first bony fish. Among these bony fish, one group stood out, the lobe-finned fish, or Sarcopterygians. With fleshy, muscular fins supported by bones, they held the evolutionary blueprint for limbs. Around 400 million years ago, during the Devonian period, often called the Age of Fishes, Earth's oceans teemed with diverse aquatic life. Among the stars of this era were the lobe-finned fish, which included ancestors of both amphibians and modern lungfish. These fish had a unique adaptation. Their fins contained bones arranged in a pattern similar to the limbs of tetrapods. But the real game changer wasn't just in their fins. It was in their lungs. Yes, lungs. Some of these fish had evolved air-breathing organs, allowing them to gulp oxygen directly from the air, a crucial survival trait in oxygen-poor waters.
The undersea megathrust rupture lifted the seafloor by several meters, displacing an enormous volume of water. Tsunami waves began racing outward at jetliner speeds, up to 800 kilometers per hour.
It had scales and gills like a fish, but also lungs and a flat head that could lift out of water. Its pectoral fins contained wrist-like bones, strong enough to support its body in shallow water or even on land. This blend of aquatic and terrestrial features makes Tiktaalik one of the most iconic missing links in evolutionary science. Yet Tiktaalik was not alone. Other transitional forms like Acanthostega and Ichthyostega also walked the evolutionary tightrope between sea and shore. Acanthostega still had gills and a fish-like tail, but it also had digits, proto-fingers that hinted at a future where fins would become feet. Together, these species illuminate a slow but steady progression, not a sudden leap, but millions of years of gradual change shaped by environmental pressures. Nature wasn't in a hurry, but it was deliberate. Around 360 million years ago, some of these pioneering fish tetrapods made their way out of the water entirely. They faced a whole new world of challenges: gravity, dry air, and harsh sun. Their bodies, once designed to swim, now needed to evolve to cope with Earth's dry surface. The first amphibians had to master life on land, and they did so in incredible ways. One of the first hurdles to overcome was respiration. While gills worked perfectly in water, they were useless on land. Early amphibians adapted by developing more advanced lungs, allowing them to breathe air efficiently. Some amphibians retained gills for their aquatic life stages, but others, like the Rhipidistions, began using lungs almost exclusively, an adaptation that would continue to evolve in land-dwelling vertebrates. Another key change was the development of stronger, sturdier limbs. The early amphibians had robust, muscular legs to bear the weight of their bodies on land. These were no longer just fins, but true legs capable of walking, hopping, and later, running. These early tetrapods also had to adapt to reproduction in a completely new environment. Unlike fish, which laid their eggs in water, amphibians needed to lay eggs in moist environments to avoid desiccation. This led to the development of jelly-like egg coverings. But the biggest evolutionary breakthrough? The ability to hear sounds in the air. Amphibians developed early forms of the eardrum, a crucial feature that would evolve over millions of years into the sophisticated hearing abilities seen in land animals today. While these amphibians were still tied to water, they were no longer fully aquatic. They were now capable of venturing further onto land, surviving in habitats as varied as wetlands, marshes, and forests. The world was slowly transforming, and these amphibians were leading the charge. But as land ecosystems grew more complex, so did the pressures of evolution. Survival required more than just limbs and lungs. It demanded innovation. As the Carboniferous period unfolded around 359 to 299 million years ago, Earth saw vast swamp forests, high humidity, and an explosion of plant and animal life. This was the golden age of amphibians. They flourished in these warm, wet environments, growing larger and more diverse than ever before. Some species, like Eriops, grew up to 2 meters long and resembled modern crocodiles, powerful hunters with sharp teeth and muscular legs. But even during their peak, amphibians were limited. Their reproduction still tied them to water. Their skin, soft and moist, required constant hydration. Then came one of the most revolutionary changes in vertebrate evolution: the amniotic egg. Unlike amphibian eggs, which dried out quickly, the amniotic egg had a protective shell and fluid-filled membranes. It allowed embryos to develop on dry land, safe from predators and desiccation. This innovation paved the way for a new class of vertebrates, reptiles. The first reptiles, such as Hylonomus, were small, lizard-like creatures that could fully sever their ties to water. They had dry, scaly skin to retain moisture and more efficient lungs suited for terrestrial life. Unlike amphibians, they could thrive in dry environments, deserts, highlands, and far beyond the reach of wetlands. With this breakthrough, vertebrate life on Earth had unlocked an entirely new domain. The dominance of amphibians would slowly wane, giving rise to a new age, the age of reptiles. This shift was not just a change in form, but a revolution in strategy. Amphibians were pioneers, but reptiles were conquerors. The journey from water to land wasn't just a chapter in the history of life, it was a defining moment that made every land vertebrate possible. From the tiniest frog to the towering dinosaurs, from early mammals to human beings, we are all descendants of that first fish who dared to step out of water. Our limbs, our lungs, even our ears, all carry evolutionary echoes of those pioneering tetrapods. When you walk, swim, or breathe, you're using tools millions of years in the making. Consider this. The same bone structure, humerus, radius, ulna, exists in a human arm, a bird wing, a whale flipper, and the fin of a lobe-finned fish. That's not coincidence, it's common ancestry. Fossils like Tiktaalik didn't just answer old questions, they opened new ones. How do species adapt to new environments? What drives such radical transformation? The fish to amphibian transition reminds us that evolution doesn't happen in straight lines. It's messy, experimental, and incredibly creative. It's also still happening. Amphibians today are some of the most endangered species on Earth, vulnerable to pollution, habitat loss, and climate change. By protecting them, we're honoring our evolutionary roots and preserving one of the most extraordinary chapters in life's story. The next time you see a frog leap or a salamander crawl, remember, it's carrying the memory of oceans past and the spirit of evolutionary boldness.